We're simplifying radicals in these next couple of problems, and so keep in mind the numbers that you know. We can split up square root of 20 into square root of 4, square root of 5. I do that because I know the square root of 4 is 2. That's how you simplify that radical. Do not try to split it into like square root of 10 times the square root of 2. Even though you can do that, it's not useful because I don't know those square roots. So that's not the way to go. Square root of 54, I split it into 9 times 6. Square root of 9 is 3, so I've got 3 times the square root of 6. Square root of negative 54. All right, negative is going to have an I on it, so it's basically the exact same thing as number 20. Split it into a 9 and a 6, but just understand that your negative is going to make this imaginary. You're going to have a 3 and an I and a square root of 6. Square root of negative 16, well, that's easy because we know the square root of 16 is 4. So it's going to have an I on it. Square root of negative 48. Okay, 48. Look at what goes into 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. I look at these numbers, and I don't want to use the ones that I don't know square roots of. So I wouldn't use any of those combinations. You have to look for numbers you know the square roots of, like square root of 4 or square root of 16, to pick the big one. You always pick the big one, so that way you don't have to simplify any further. Square root of 16 times square root of 3 with an I because it's got a negative. We get 4I times the square root of 3. Square root of negative 98. Well, it really helps if you know the perfect squares. But maybe you recognize that 49 times 2 is equal to 98. So square root of 49 times square root of 2 with an I on it. That is 7I times the square root of 2. Next, we're all about like terms. We're simplifying like terms, and you know, one thing to notice is it's kind of like distributing a negative here. So minus negative 4 would be plus 4, and minus negative 5i would be plus 5i. So I suppose you could completely rewrite the problem without the parentheses. We're looking at like terms. Negative 8 plus 4 is negative 4. Negative 4i plus 5i is plus I. Next one is very straightforward. Just combine your like terms. Next one, multiplication. Negative 4 times negative 4 is 16. I times I is I squared. So here's where we have to remember, and here's where we have to know that I squared is equal to negative 1. So if I squared is equal to negative 1, we have 16 times negative 1. 16 times negative 1 is negative 16. You're multiplying a binomial times a binomial, you distribute the negative 1. And then you distribute the negative I. We have like terms here, but we also have an I squared. Remember, I squared is negative 1. So I would see negative 8 plus 1 is negative 7. Negative I minus 8i is negative 9i. 29 and 30 are not simplified because there's an I on the bottom of the fraction. 29 is pretty easy to remedy because all we have to do is multiply by I over I. What we're trying to do is get an I squared on the bottom because I squared is going to turn into negative 1. Oops. Put the negative with the 6, just treat it like that. Negative 6 times I is negative 6i. And on the bottom, you have 10i times I is 10i squared. We know I squared is negative 1. So we have negative 6i over 10 times negative 1 is negative 10. We have a reducible fraction. Of course, negative over negative is positive, but also 6/10 reduces to 3/5. I'm looking at 3i over 5. Number 30 is the weird one. 5 minus 3i, you can't do the same thing. If you tried to do the same trick, the problem is you're just going to distribute and end up with the I over here. The I will be on the 5 instead of on the 3. That's not going to work, so you can't do the same thing. What you have to do is look at the bottom and say, we're going to multiply by the conjugate. If that says 5 minus 3i, we're going to multiply by 5 plus 3i. Top and bottom, because that over itself is 1, we're really multiplying the problem by 1, which doesn't change the value of the problem at all. So on the top, we distribute, and we get 25i plus 15i squared. And then on the bottom, distribute. 5 times 5 is 25, 5 times 3i is plus 15i. And then we distribute here, negative 3i times 5 is minus 15i, and negative 3i times 3i is minus 9i squared. So several things happen at this point. Number one, these two cancel each other out. That's kind of the big idea. That's the secret. That's what makes this thing go. We also have a couple of I squareds, which we know are negative 1. And so let's clean this thing up. On the top, I would see 25i, 15 times negative 1 is negative 15. On the bottom, we have negative 9 times negative 1 is plus 9 here. So 25 plus 9 is 34. That's not reducible, and you can tell because you can't cancel. You can't cancel all 3 of them. So we can leave the answer like that. If you wanted to, you could split it like this. I don't care. Either way.